Hello everyone. In this video, we're going to speak about how pointers are different to references. So we've got our integer declaration of variable age and our pointer declaration of an age pointer. And what we want to do is we want to show how pointers could be different to references. And the main difference that I'm going to speak about in this video is how you can change what the pointer points to later during the program. This is something that we cannot do with references. So I'm going to show you what that means. If I declare another variable of integer named age2 and I give it a value of 40, and then what I'm going to do is I don't need to declare this again, I just need to give it a new value. So this time age2. Okay, so we'd like to see how this changes the pointer. So let's print the value and the address of age2. So let's see out of age2. So this is the value of age2. Let's print it out here and end the line. And then what we want to do is also we want to do the address. So the same thing over here. Address. So this is the value of age2. This is the address of age2. Now don't forget to make it print out the address. We just need to use the ampersand operator. Okay. And now what we want to do is do the same thing, but for a pointer. So to print the value of the pointer, what we need to do is we need to dereference it using the asterisk operator, or the dereference. We are dereferencing it over here. And then to print out the address, we just simply print it out like this, because that's what's sitting on our pointer. And we spoke about this in our previous video. Okay, so previously, let me just do the same over here though. So something that I missed to include from the previous video, let's print the value and address of age, just age, and print out the value of pointer. Yep. Okay, so let's compile and run. Okay. Let's see what we get. So the value of age is 30, and I just need the space there. And the address of age is this address. And then we're looking at the value of the pointer, which is 30, and the address that is sitting at the pointer is the same memory address of age. And then what we've done here is we've declared another integer variable of age2. And we've made the pointer, or we've changed where the pointer is pointing to. So now the pointer, instead of pointing to this memory address, it now points to the memory address of age2. So let's have a look at the value of age2. That's 40. And the address of age2 is this value over here. And the value of the pointer now also becomes 40. And the address that is sitting at the pointer is now the address of age2. So it's no longer storing this memory address, it is now storing this memory address. This is something we cannot do with references, and I'm going to show you how. But let me just put in some spaces over here, just because it looks bad. It's something I missed, and I'll probably execute this again just to show you that it looks a bit better now at this point. Okay, so here is what we have. So you can see that this is something we cannot do with references. And that's something I think I've mentioned it here. Something we cannot do using references is we actually can change what the pointer's pointing to later on during our program. And we can actually witness this. So previously at this line, it was actually pointing to the memory address of age, whereas later on we made it refer to H2, to the address of H2. So now it's actually pointing to a different memory address. Okay, now let's show how this cannot be happening with references. So let's declare our reference. So if you remember from our video probably 27, we showed how to declare a reference. So I'm gonna start by saying integer, and with references we use the ampersand sign or operator instead of the asterisk, as opposed to the pointer declaration. So this is pointer declaration. This is reference declaration. Okay, now I'm going to call my reference something similar to what we've called the pointer, but I just want to end it with ref, so that we can tell that this is this is a reference rather than a pointer. Now you notice that with pointer declaration, you actually had to explicitly give the ampersand operator to let it know that you would like to store the memory address of age, whereas this is something that is implicitly happening with references. So you don't really need to mention the address using the ampersand operator. Okay, so what we want to do is let's print out the values of these variables. So I might need this. So age, yep. Before we show what's happening. So the value of age. So we've still got age and the address of age, just repeating ourselves, and the value of our reference, and we don't need the dereference over here, and the address of the reference, and we need to use the ampersand operator. And what happens here is just pretty much yeah, so we've just declared our reference, nothing much is happening. Let's have a look at that. And so we've already explained this part and this part. Sorry, I was meaning to highlight this part. Let's declare the reference. So the value of age is 30 and the address of age is pretty much the same as what we had in memory address. And a value of the reference is also 30, and the address is the same as the memory address of age. Okay, so here we want to demonstrate how we can't really change the reference. So what we want to do is make this point to H2. This is the variable that we declared here, okay, which was 40. So what really happens here is what we've done is we've only, sorry, I'm here. What we've done here is we only changed the value of the reference to 40. That's pretty much what's happening here. But let's show some facts on how this is happening. So let's print out the value of, let's do this whole thing again. Okay, and let's put it in here. The value of age pretty much remains the same. The address of age pretty much remains the same. And we just want to show how the addresses, because what we have is age over here can be referenced through the age variable and through the reference and age ref. Okay, so we'd like to still see how that looks. And then do this for H2 and address of H2 and H2. So let's compile and see what we get. And run. Let's look at this part. where we can't change the reference. So the value of age becomes 40, because that's what we pretty much did over here. We've only changed the value of the reference, but we cannot change the actual memory location that the reference is referring to. And the address of age pretty much remains the same. The value of age is 40, and the memory address is also the same as age. But notice that the value of age 2 is also 40, but the address is different. So I think I've mentioned it somewhere here. We notice that age and ageref are independent of h2. So let's actually prove it. So what we want to do is we want to change the value of age to 42. If I make this equal to 42, 44. Yeah, I don't know where I got 42 from. But if we change the value of age to 44, we notice that age and ageref are independent of age 2. How do we know that? Let's print all these details again and print out. And I'm not really changing anything here, but we want to look at this line over here when we execute it. Okay. So if we change the value of h2 to 44, does the reference get affected? No, because the reference still has the value 44 and the same reference as the memory address of age. The value is still 44, and you'll notice that it's independent of the memory address of h2. So nothing changes, okay? But the value of h2 becomes 44, but that doesn't affect our reference and our age variable whatsoever. But the question is, does the pointer get affected now that we've changed the value of h2? If you remember over here, we've actually changed what the pointer points to h2. So it previously was pointing to this address, which is the address of memory address of the variable h2, and it used to hold the value 40. Does this affect now that we've changed h2 to 44? Let's have a look. Oh, this line over here. So does the pointer get affected? And I've given you the short answer here. It's yes, but with the reference I've said no. But let's demonstrate why we're getting that. And okay, so I need, this is where I'm looking at. Okay, and what we want to do is print out the value of this one. Okay, that's what we want. So whereas the pointer changed to align with h2, since it holds the memory address, of h2 now. Okay, so nothing pretty much changes. I don't need to print out the value and the address of h2 because that's already here, and we can just look at that. Okay, so you notice that the pointer, the pointer is pretty much pointing to the memory address of h2, and it also holds that new value of 44. So I hope this is enough evidence for you to see that we can change or probably prove this line. We can change what the pointer points to later on during the program, because initially we made the pointer point to the memory address of age, and then at some point we changed that. But this is something we cannot do with references, and I hope this was enough explanation on this line, basically why and why not. So I hope this helped, and I'll see you in future videos. Thank you so much.